Hey, welcome back. Years ago, I used to ask my students a question. It was, imagine you had a ball as big as the sun, and what you wanted to do was you have a belt around that, around the equator of that ball, and you're asked to take that belt and make it longer by just 1 yard. And the question is, would that 1 yard be enough to lift that belt off the earth or the ball big enough to slip a playing card underneath it, to slip your hand underneath it, or what about a baseball? Now, different groups solved it different ways. In geometry, students would research, well, what's the radius of the sun? They would calculate the radius, and then they would convert that to yards, and then they would solve the problem in that way. They did some humongous numbers, a lot of subtraction. Most students always solved it that way. But my calculus students know a different way. And that's what I'm going to show you today. It's called differentials. So here's an application of the differentials. So imagine again, like I said, we have a ball as big as the sun right there. And around that we have a belt. We are going to just add 1 yard to that belt. So that's going to change our circumference. We can use differentials to approximate this. Now we know the circumference of our belt would be 2 pi r. Well, remember, a differential finds the change or the error in a certain of a variable. So what I'm being asked here to find is the change in r, dr. How is the radius changing? So to solve this, I can find my differential, take the derivative of my circumference with respect to r, so dc dr, and that's just going to equal 2 pi. Solving for the differential, dc would equal 2 pi dr. Whoop, that's 2c, sorry. dc should equal that. Now, remember, we're adding 1 yard. Well, what is this going to change? Well, this changes the circumference. So therefore, we know the change in circumference is 1. So I can put that 1 right over here, and I get 2 pi dr. I want to find how much my radius will change. And let's see how much the radius will change here. dr would be 1 over 2 pi yards. Now that doesn't seem like much, but let's see what that turns out to be. Ready? If I take my ever-trusting calculator, I take 1 divided by 2 pi. I press enter. Whoops, I hate when it does that. That gives me 0.159 yards, which is about how many inches? Well, there are 36 inches to a yard, which is about, oh my gosh, 5.73 inches. So think about this. All this says is if I take a ball as big as the sun and I increase the diameter of the belt around it by 1 yard, it's going to lift off the sun by have a change in radius of about 5.7 inches all around the sun. Interesting. And that is big enough to fit a playing card, your hand, and even a baseball underneath. Now again, this is only an approximation technique. To get the actual answer, you'd have to use those big numbers that my geometry students would use. Anyways, I do hope you enjoyed this application of differentials. It's kind of a fun thing to do. Bye-bye.